David Perry's Spacewalk Drive Feasibility Studies, presented by Mantim Lee, date October 2022. Introduction. My name is Mantim Lee. I am 70 years old, living in Singapore. I am a retired engineer, experienced in electromechanical repair and maintenance of steam sterilization equipment in hospitals. I wish to share with the knowledge seekers that I did an analysis feasibility study on the David Perry's spacewalk craft, as per photograph. Professor David Perry's, he is doing research on spacewalk. His proposed design is as per video source. YouTube. Can you build a warp drive in a garage? By the good stuff. My presentation here shall analyze its working principles with mechanics, electrostatics, electromagnetics, and the feasibility to implement warp drive with known electronic circuits. Spacewalk phenomenon. Mr. Bruce Gernon, a pilot, experienced flight off course as he was running out of fuel that he had to take the risk to fly through a cloud tunnel in an unexpected thunderstorm. To an outside observer, I may understand the phenomenon of thunderstorm as due to electrostatics, plus the air turbulence within the cloud tunnel could have caused the airplane to traverse an extra 90 miles in 28 minutes. That is 192.86 miles per hour. Professor David Perry studied the phenomenon and recreated it as a local compression in the fabric of space, a spacewalk phenomenon. Source: YouTube. Can you build a warp drive in a garage? By the good stuff. Fractal antenna of rainstorm pattern. Professor David Perry recreated the cloud pattern with copper printed circuit boards as in these pictures. My interpretation of a fractal rainstorm pattern are miniature lumps of air in the shape of cloud under the antenna enclosed by positive electrodes. The two plates of electrodes are 90 degrees to each other. It created a 45-degree component electric field to the empty space embraced by the electrodes. The charges Q are distributed along the copper. The electric field could be in spherical directions. Some field lines may be blocked by the antenna shape. Only one resultant vector E is accounted for simplicity. When the antenna is placed in the Earth environment, the cloud pattern is an array of air lumps surrounded by positive charges, electrodes, along the antenna. When in space, the cloud pattern are lumps of empty space surrounded by positive charge likewise. To understand the array of electrodes as an antenna, it has the understanding that the shape and charges information can be transmitted to far away distance, as an electromagnetic wave would transmit, like our present-day radio. At the antenna, the electric field is an open field, exposed to the open environment, an open dynamic electric field. The antenna transmitting electromagnetic wave, it may interact with objects far away. Antenna transmission. The fractal antenna is supplied with UHF, ultra-high frequency, like our present-day television transmission. UHF spectrum range is 300 MHz to 3 GHz. UHF is used in space telemetry. We know that it can reach out to space. We may use the electric field concept to explain the spacewalk pulling force. The Coulomb definition of electrostatic field. F equal to KQQ divided by R squared. Electric field equal to force per unit charge. K equal to 1 over 4 pi epsilon, electrostatic constant. Electric field E equal to KQ divided by R squared, Newton per Coulomb. When a test charge Q is placed in the electric field at R meters away, Q shall experience a force, F equal to Q times E. In the case of an antenna, the electric field is dynamic, change with time, and in calculus differential format, it would be dE dt. The force origin is electrostatics. The dynamic field is electromagnetic wave. Electromagnetic wave. In an antenna, the tube is positively polarized. As current flow into the antenna wire, electrons flow out, extracting electrons from the tip and draining electrons back into the circuit via the antenna ground. That positive polarized tube, positive charges are exposed along the geometric shape of the antenna, is equivalent to lumps of thunderstorm cloud charges, summation into a bigger charge Q, and increased Q. When the current flow is alternating, vibrating as according to the frequency F in the oscillator circuit, the current that flow out of the antenna, electrons would flow back in to the antenna tube, neutralizing a part of Q, summation into a smaller Q, a decreased Q. This Q changes with time is dQ dt. The vibrating charge Q generates a vibrating electric field dE dt. The vibrating Q is current dQ dt. Vibrating current generates a vibrating magnetic field dB dt. This results in a vibrating electromagnetic field at the antenna tube. The EM field changes with time are dQ dt, dE dt, dB dt. The E comes from Q and B comes from E. This field changes with time created electromagnetic wave with vibrating frequency F. The antenna transmits electromagnetic wave is a packet information of dQ dt, dE dt, dB dt, and F. Since E equal to F divided by Q equal to KQ divided by R squared, implied partial dE dt equal to K divided by R squared, partial dQ dt, equal to K divided by R times I divided by R, equal to K divided by R times H. As H equal to I divided by R ampere per meter, I equal to partial dQ dt. Partial dH dt equal to 1 over R, partial di dt equal to 1 over r second derivative dq dt squared. B equal to mu naught h imply partial dh dt equal to 1 over mu naught partial dB dt. Partial derivatives only change one variable at a time. Aligning the above relationship, we have second derivative of dE dt squared equal to partial second derivative dE dt squared. This cyclic relationship between derivatives dq dt, dE dt, dB dt give rise to a wave equation. Second derivative of dE dt squared equal to omega squared times E. In mathematics, we found these cyclic characteristics in the sine function. For example, E equal to E naught sine omega t. The first derivative dE dt equal to E naught times omega cosine omega t. Second derivative dE squared dt squared equal to omega squared E naught sine omega t equal to omega squared E. It comes back to the sine function sine omega t. The term E naught times omega and E naught omega squared bring motion to E. Since E omega equal to 2 pi f, the angular speed omega in radian per second brings in the frequency f as well. We think of the first derivative as velocity, second derivative as acceleration. We see why that E equal to E naught sine omega t shall transmit electromagnetic wave, the EM wave, in motion to faraway distance, a traveling E field. Swap phenomenon. In Professor David Parry's modified Cavendish experiment, the test charge was neutral, a suspended Ferris ball. The iron atoms Fe has 26 electrons. Fe has up to 4 free electrons that can move around. The other 22 electrons are core electrons that prefer to move along with the protons. When the electrons negative in iron sees the positive charge electric field, the electrons are attracted to the changing electric field dE dt. The force origin is electrostatics, F equal to E times Q. The Ferris ball is neutral, not charged, as when the incoming UHF photon energy insufficient to ionize Fe. The dE dt disturbed electrons is like a stretched spring. The Fe atoms would naturally spring back to its undisturbed condition. The proton eventually moved along with the electrons towards the electric field, shall explain the optical deflection, which confirmed motion. The electrons' distribution in Fe is moved by the external electric field. The Fe protons also being dragged along by electrons towards the electric field, experienced as an attractive force, an acceleration compatible to Earth g, equal to 9.8 meter per second square. It is analogous to gravity. If we set Earth warp equal to 1g, we shall find out the warp caused by acceleration of the test Ferris ball. Modified Cavendish experiment. Professor David Parris did this experiment with result. A 1.5 pound Ferris ball at a distance of 35 cm away caused an optical deflection, confirmed the movement of the Ferris ball towards the fractal cloud thunderstorm pattern antenna. The antenna used was 650 watts for 15 seconds, and the largest deflection was 18 cm. From this experimental result, I can calculate that work done equal to 650 Newton meter per second times 15 seconds equal to 9,750 Newton meter. Work done equal to force times distance equal to attractive force times deflection equal to ma times 0.18. Setting Ferris ball mass m equal to 0.6818 kg, a equal to acceleration, then force equal to mass times acceleration. A equal to 9,750 Newton meter divided by 0.18 meter divided by 0.16818 kilogram equal to 79,446 meter per second square. This compares with the Earth's gravitational acceleration g equal to 9.8 meter per second square. The Ferris ball would have experienced 79,446 divided by 9.8 equal to 8,107 g-force is too large. This acceleration is too large. I need to scale back that 18 cm deflection. It might have magnified 10,000 times. Scaling back A equal to 79,444 divided by 10,000 equal to 7.9745 meter per second square. Then 7.9745 divided by 9.8 equal to 0.81 g-force. It seems reasonable. If we set the Earth gravity as warp equal to 1, then the antenna caused warp equal to 0.81 at 35 cm away. Gravity. The YouTube Mud Fossil University. Roger has a concise way of explaining gravity. That is, proton positive attracts an electron, and that same electron attached with matter will attract along with it. This is gravity. The David Parris modified Cavendish experiment result indicated it does not take the mass of the whole Earth to warp the fabric of space. A 1.5 pound Ferris ball could warp space. The movement of an object, it exerts acceleration in the direction of motion. That acceleration is analogous to warping the space in front. This means cars on the roads are already warping space in our daily life experience. Bluebird 2. On the Bluebird 2 model, at the cockpit area, I see an array of antennas. When this antenna points to a distant planet, the electric field on the antenna is expected to interact with the planetary matter. The dynamic electric field, and hence the electric force at a distance, shall pull the Bluebird model spacecraft towards the planet. This artificial force strain, compatible with gravity acceleration, g equal to 9.8 meter per second square, is gravity. From the experimental result, the electrical energy used equal to 650 watts. As calculated in previous slide 10, at short distance 35 cm, its acceleration equal to 7.9745 meter per second square. It warps at 0.81 g. From the experimental result, electrical energy used equal to 650 watts. We know that electrical energy equal to V squared divided by R. Taking the square root, V equal to square root of energy times R. I can estimate that V equal to square root of 650 equal to 25.4951 volts. Round off, V equal to 25 volts. Normalized, R equal to 1. Electric field is also related to voltage. Electric field equal to Newton per Coulomb equal to volt per meter, as volt equal to joules per Coulomb equal to Newton meter per Coulomb. To increase the electric field, we increase the voltage. 25 volt can interact with 1.5 pounds or 0.6818 kilogram. To interact with a person weight 100 kilogram, we would have to use 25 divided by 0.6818 times 100 equal to 3,667 volts. I wish to hyperdrive its power to use 14,400 volts. Check by proportion. 650 watt divided by 25 volt times 14,400 volt equal to 374,400 watt. Then mass equal to 374,400 Newton meter per second times 15 seconds divided by 9.8 meter per second square divided by 0.18 meter divided by 10,000 equal to 318 kilogram. Warps at 1 g 35 cm away. Our present day's electricity supply distribution are using these AC high voltages. High voltage distribution at 14.4 kV. Very high voltage distribution at 33 kV. Ultra high voltage distribution at 1000 kV. This presentation we shall be based on 14,400 volts, as this voltage is attainable with a mini Tesla coil, and its current flow, amperage less than 1 ampere, is manageable by known electronic circuits. Transverse motion. Professor David Parris' experiment used UHF to warp space. In my study, I came across the Alex Chekhakov Demagnetizer circuit, which oscillates at the transistor's natural frequency, Ft equal to 40 MHz, presented in my previous video. Alex Shekharkov Liftcraft with Circuit Analysis, YouTube, by Mantim Lee. By replacement of the transistor KT815A into a higher frequency transistor KT3102EM, the natural frequency Ft equal to 300 MHz. This is the beginning of the UHF wave spectrum. This circuit, as it is, the output is 480 volts. To enhance the electric field further, we can change T2 step-up transformer with a mini Tesla coil. Input voltage 12 minus CEZ equal to 12 minus 0.25 equal to 11.75 volt. Output equal to 14,400 volt. Transformer turn ratio N equal to 14,400 divided by 11.75 equal to 1,225, or 2.5 turn to 3,064 turns, using AWG28. Transistors spec IC max equal to 200 milliamp equal to 0.2 amp. Transformer T2 VA equal to 11.75 times 0.2 equal to 2.35 VA. Output 2.35 to 14,400 equal to 163 microampere. Antenna power consumption 2.3 VA equal to 2.35 watt. Circuit consumption equal to 0.2 square times 1K equal to 40 watt. 47 megohm in microwatt. 51K in milliwatt, negligible. Scaled interaction equal to 0.6818 divided by 25 times 14,400 equal to 392 kilogram. This electric field created by high voltage, 14,400, the UHF connected to the antenna may set an interaction with the suspended ferrous ball of 392 kg at 35 cm away. When this electric field points to a heavy object, to a planet, the larger inertial planet shall not move. It may pull a spacecraft of mass 392 kg. Transistor source, alldatasheet.com. Putting 6 units of these circuits in parallel, it may pull 2,352 kg. This is equivalent to a car-sized spacecraft plus payload. Frequency tuning. I came across Dr. Ling Li's video, indicated that core electrons is one of the conditions to atomic motion. When the core electrons move, the nucleus moves along. Source: YouTube, Gravity Modification by Space Activist Archive. My next problem is to check whether 300 MHz is sufficient to move the core electrons of iron, aluminum, silicon. These are our abundant elements on Earth to assist the spacecraft liftoff. The Bohr atomic model. On the internet, I found the Bohr model deduction for hydrogen. E total equal to minus RH bracket 1 over N1 square minus 1 over N2 square. Source: YouTube. What is the model of the atom? I follow a similar deduction as follows. Electron centrifugal force equal to ME V square divided by R. ME is the electron mass. Coulomb force KQE divided by R square. K equal to electrostatic constant equal to 1 over 4 pi epsilon. Q equal to atomic number of proton, Z times E plus. Then E plus E minor equal to E equal to 1.6021 times 10 to the power minus 19 Coulomb. E total equal to kinetic energy plus potential energy equal to half ME V square minus ZZ E2 divided by 4R pi epsilon. Setting centrifugal force equal to Coulomb force, then 1R cancel out. MeV square equal to Z E square divided by 4R pi epsilon. Substitute MeV square equal to KQE divided by R into total. Then E total equal to 1/2 Z E square divided by 4R pi epsilon minus CE square divided by 4R pi epsilon equal to minus CE square divided by 8R pi epsilon. From previous slide, E total equal to minus Z E square divided by 8 pi epsilon R. Minus means we need to input energy. The Bohr model of atom introduced the quantization of angular momentum of electrons. L equal to ME VR equal to NH divided by 2 pi, where N equal to atomic orbital quantum number. Then R equal to NH divided by 2 pi MeV, equation 1. And MeV square equal to KQE divided by R equal to Z E square divided by 4 pi epsilon naught R, equation 2. Q equal to ZE. From equation 2, V square equal to C E square divided by 4 pi epsilon MER. From 1, R square equal to N square H square divided by 4 pi square divided by ME square divided by V square, equation 3. Substitute V square into equation 3. R square equal to N square H square divided by 4 pi square ME square divided by ZE square divided by 4 pi epsilon naught MER. R square equal to N square H square times 4 pi epsilon naught MER divided by 4 pi square me square divided by ze square, imply r equal to n square h square times epsilon naught divided by pi me divided by ze square. The 4 pi me and 1 r cancel out. Substitute r into E total equal to minus z square divided by 8 pi epsilon naught r equal to minus z square divided by 8 pi epsilon naught times n square h square epsilon naught divided by pi me c square equal to minus z square times pi me c square divided by 8 pi epsilon naught divided by n square h square epsilon naught equal to minus z square e to the power 4 times me divided by 8 epsilon naught square h square n square. The pi cancel out. Substituting values, E equal to 1.6021 times 10 to the power 19 C, me equal to 9.1091 times 10 to the power minus 31 kilogram, H equal to 6.256 times 10 to the power minus 34 joule seconds, Z equal to 26, epsilon naught equal to 8.8542 times 10 to the power minus 12 coulomb square per Newton meter square. We have tuning to INFE, E total equal to minus 26 square times 1.6021 times 10 to the power 19 to the power 4 times 9.1091 times 10 to the power minus 31 divided by 8 divided by 8.85 times 10 to the power minus 12 square divided by 6.256 times 10 to the power minus 34 square divided by n square equal to minus 26 square times 6.5881 times 10 to the power minus 76 times 9.1091 times 10 to the power minus 31 divided by 8 divided by 78.3225 times 10 to the power minus 24 divided by 39.1375 times 10 to the power minus 68 divided by n square equal to minus 26 square times 60.0110 times 10 to the power minus 107 divided by 24,522.7748 times 10 to the power minus 92 divided by n square equal to minus 26 square times 0.0024 times 10 to the power minus 15 divided by n square equal to minus 1.6224 times 10 to the power minus 15 times 1 over n square joules. Note, I calculate step by step to deal with decimals first and the exponents the last. From this point onward, I can use this formula minus c squared times 0.0024 times 10 to the power minus 15 divided by n squared joules is the total energy of an electron in orbit n for an element with atomic number Z. The ion electrons configuration is 2, 8, 14, 2. Core electrons shall have to jump from third orbital to fourth orbital. Delta E equal to 1.6224 times 10 to the power minus 15 times 1 over 3 square minus 1 over 4 square equal to 1.6224 times 10 to the power minus 15 times 0.1111 minus 0.0625 equal to 1.6224 times 10 to the power minus 15 times 0.0486 equal to 0.0788 times 10 to the power minus 15 joules. The photon frequency F equal to delta E divided by H equal to 0.0788 times 10 to the power minus 15 divided by 6.256 times 10 to the power minus 34 equal to 0.0126 times 10 to the power 19 Hertz equal to 126,000 times 10 to the power 12 Hertz equal to 126,000 terahertz. 126,000 terahertz is ultraviolet frequency range compared to UHF equal to 300 megahertz equal to 0.0003 terahertz. 1 tera equal to 10 to the power 12. Big F equal to n plus 1 times small f. 126,000 equal to 0.0003 times n plus 1. N equal to 419.99999 times 10 to the power 6. That is 420 millionth harmonic of ion Fe. This calculation indicated that it takes ultraviolet frequency to move the orbital of core electrons of ion. UHF 300 MHz is a tiny harmonic frequency to resonate the core electrons of ion Fe and not to ionize the element. Tuning to aluminium. Next, we consider aluminium. Z equal to 13, configuration 283. The core electrons will have to move from n equal to 2 to n equal to 3. Then, delta E equal to 13 square times 0.0024 times 10 to the power minus 15 times 1 over 2 square minus 1 over 3 square equal to 169 times 0.0024 times 10 to the power minus 15 times 0.25 minus 0.1111 equal to 169 times 0.0024 times 10 to the power minus 15 times 0.1389 equal to 0.0563 times 10 to the power minus 15 joules. The photon frequency F delta E divided by H equal to 0.0563 times 10 to the power minus 15 divided by 6.256 times 10 to the power minus 34 equal to 0.0090 times 10 to the power 19 Hz equal to 90,000 terahertz. Compared to UHF 300 MHz equal to 0.0003 terahertz. 90,000 equal to 0.0003 times n plus 1. We have n equal to 29.9999 times 10 to the power 6. That is 30 millionth harmonic of aluminum. Note, first harmonic equal to 2 times wavelength equal to 2 lambda. Then F equal to C divided by 2 lambda equal to big F divided by 2. Nth harmonic equal to n plus 1 times wavelength. Then small f equal to C divided by n plus 1 lambda. Imply that F big F equal to n plus 1 small f. The big F is the higher frequency. Small f is the lower frequency. Harmonic frequency is the use of lower frequency to resonate the higher frequency. Tuning to silicon. Lastly, we consider silicon. Z equal to 14. Electrons configuration 284. The core electrons will have to move from n equal to 2 to n equal to 3. Then delta E equal to 14 squared times 0.0024 times 10 to the power minus 15 times 0.25 minus 0.1111 equal to 196 times 0.0024 times 10 to the power minus 15 times 0.1389 equal to 0.0653 times 10 to the power minus 15 joules. The Floquant frequency F equal to delta E divided by H equal to 0.0653 times 10 to the power minus 15 divided by 6.256 times 10 to the power minus 34 equal to 0.0104 times 10 to the power 19 equal to 104,000 terahertz. Compared to UHF, 104,000 equal to n plus 1 times 0.0003, n equal to 346.6666 times 10 to the power 6, that is 347 millionth harmonic of silicon. These calculations indicated that the core electrons' frequencies are 100 million times higher than that of UHF 300 MHz. As a tiny harmonic frequency, it offers a possibility to resonate with the core electrons in iron, aluminum, and silicon, which are relatively abundant on Earth, Moon, and Mars. Minerals on planet crust: Earth, iron 4.7%, aluminum 7.6%, silicon 25.8%, the Moon, iron 12%, aluminum 5%, silicon 21%, Mars, iron 9.8%, aluminum 6.2%, silicon 23.5%. Estimate from rock: Mars silicon dioxide 55% times Earth silicon 25.8% divided by Earth silicon dioxide 60.2% equal to 23.5%. Tuning to atmospheric element oxygen. I consider oxygen C equal to 8, configuration 2,6. The core electrons will have to move from n equal to 1 to n equal to 2. Then delta E equal to 8 squared times 0.0024 times 10 to the power minus 15 times 1 minus 0.25 equal to 64 times 0.0024 times 10 to the power minus 15 times 0.75 equal to 0.1152 times 10 to the power minus 15 joules. Photon frequency F equal to delta E divided by H equal to 0.1152 times 10 to the power minus 15 divided by 6.256 times 10 to the power minus 34 equal to 0.0184 times 10 to the power 19. That is 184,000 terahertz. Compared to UHF, 184,000 equal to n plus 1 times 0.0003, n equal to 613.3333 times 10 to the power 6, that is 613 millionth harmonic of oxygen. Tuning to atmospheric element nitrogen. I consider nitrogen Z equal to 7, configuration 2,5. The core electrons will have to move from n equal to 1 to n equal to 2. Delta E equal to 7 squared times 0.0024 times 10 to the power minus 15 times 1 minus 0.25 equal to 49 times 0.0024 times 10 to the power minus 15 times 0.75 equal to 0.08822 times 10 to the power minus 15 joules. Photon frequency F equal to delta E divided by H equal to 0.0882 times 10 to the power minus 15 divided by 6.256 times 10 to the power minus 34 equal to 0.0141 times 10 to the power 19 equal to 141,000 terahertz. Compared to UHF, 141,000 equal to n plus 1 times 0.0003, n equal to 469.99999 times 10 to the power 6, that is 470 millionth harmonic of nitrogen. Tuning to space element hydrogen. We consider hydrogen Z equal to 1, configuration 2. The core electrons will have to move from n equal to 1 to n equal to 2. Then delta E equal to 1 squared times 0.0024 times 10 to the power minus 15 times 1 minus 0.25 equal to 1 times 0.0024 times 10 to the power minus 15 times 0.75 equal to 0.0018 times 10 to the power minus 15 joules. Photon frequency F equal to delta E divided by H equal to 0.0018 times 10 to the power minus 15 divided by 6.256 times 10 to the power minus 34 equal to 0.0003 times 10 to the power 19 equal to 3000 terahertz. Compared to UHF, 3000 equal to n plus 1 times 0.0003, n equal to 9.9999 times 10 to the power 6, that is the 10th millionth harmonic of hydrogen. Tuning to space element helium. We consider helium, C equal to 2, configuration 2. The core electrons will have to move from n equal to 1 to n equal to 2. Delta E equal to 2 square times 0.0024 times 10 to the power minus 15 times 1 minus 0.25 equal to 4 times 0.0024 times 10 to the power minus 15 times 0.75 equal to 0.0072 times 10 to the power minus 15 joules. Photon frequency, F equal to delta E divided by H equal to 0.0072 times 10 to the power minus 15 divided by 6.256 times 10 to the power minus 34 equal to 0.0012 times 10 to the power 19 equal to 12,000 terahertz. Compared to UHF, 12,000 equal to n plus 1 times 0.0003, n equal to 39.9999 times 10 to the power 6, that is 40 millionth harmonic of helium. These calculations indicated that UHF 300 MHz is a closer harmonic to the core electron frequencies of hydrogen and helium. This offers a possibility to tune in to the core electrons of Earth's atmospheric elements oxygen, nitrogen, and space elements hydrogen and helium to assist liftoff. This indicated that it may be best to point the antenna to the Sun for liftoff and transverse. Alex Chekhov Demagnetizer circuit modified. We now continue to analyze the circuit. This circuit has not a capacitor in the primary coil for the transistors to oscillate. The circuit shall oscillate in its transistor's natural frequency, as according to transistor specifications, KT3102EM, FT equal to 300 MHz UHF. As per Zinadiol specification, Z1 equal to VDZ 6.2B 6 volt DC limit IZ equal to 5 MA. 51K variable resistor trim port setting equal to 37.4 K ohm. This sets Q1 base to 37.4 K divided by 51 K times 6 volt equal to 4.4 volt DC. Q1 equal to on. Current flows out of the emitter into T2 transformer center tap, which induced a positive volt, a forward bias for Q2 equal to on. Q2 collector current draws in, reverse the current flow in T2 center tap, and stop the current to the 1K resistor on Q2 base, 0 volt. Q2 equal to off. Once Q2 is off, the current in T2 primary flows through the 1K resistor again, which induces a positive volt to Q1 emitter. Q1 equal to off. Reverse current sets Q2 base minus negative, Q2 equal to off, and the process repeats. Q1 equal to on, Q2 equal to on, Q1 equal to off, Q2 equal to off. Circuit in continuous oscillation. The next slide, we shall check the bias of the transistors and calculate the antenna capacitor C. Circuit analysis. When transistor Q1 is on, the collector to emitter has a voltage drop of VCEZ equal to 0.25 volt, KT3102EM specifications. The input voltage to the transistor T2 is 12 minus 0.25 equal to 11.75 volt. The primary winding, N1 is 5 turns, AWG 14, 1.63 mm diameter, capacity 8.3 ampere. Primary coil, thick wire to stay in shape, not to touch with the secondary. Center tap at 2.5 turns. It is like a wire, has no resistance. No voltage drop, so 11.75 sets a forward bias for the base of Q2 equal to on. Once Q2 conducts, IC equal to ICZ equal to 0.2 ampere, and the collector VCEZ equal to 0.25 volt. All the current at Q2 will drain via the Q2 emitter. This shall stop the branch current to the 1K resistor. Q2 base becomes 0 volt, shall turn Q2 equal to 0 volt, Q2 equal to off. The voltage at the center tap equal to VCEZ equal to 0.25 volt sets the emitter of Q1 equal to 0.25 volt. The bias voltage becomes 0.6 minus 0.25 equal to 0.35 volt is inadequate forward bias equal to reverse bias. It shall set Q1 equal to off. Once Q1 is off, its emitter equal to 0 volt. The Zener dial is fixed at 6 volt, setting 337.4 K divided by 51 K times 6 volt equal to 4.4 volt DC, and so it keeps Q1 from turning on again. The sequence goes on. Q1 equal to on, Q2 equal to on, Q2 equal to off, Q1 equal to off, Q1 off, Q1 on, resulting Q1 equal to on-off, Q2 equal to on-off, continuously making current flow in transformer T2. Primary coil frequency equal to transistor natural frequency, Ft equal to 300 MHz UHF. The next slide, we shall calculate the antenna capacitance C. Antenna capacitance C. The VA in primary equal to 11.75 volt times 0.28 amp equal to 2.35 VA. The secondary equal to 2.35 VA divided by 14,400 volt equal to 0.0002 ampere. Inductance reactance equal to J 14,400 volt divided by 0.0002 ampere equal to J 72 mega ohm. J is an operator to indicate voltage leading current. Capacitor reactance equal to minus J 1 over 2 pi Fc. F equal to 300 megahertz. To set the antenna in resonance, we need the capacitance to have the same reactance as the inductance in T2 secondary. 1 over 2 pi Fc equal to 72 meg. C equal to 1 over 2 pi 300 meg times 72 meg equal to 7.3683 times 10 to the power minus 18 farad equal to 736,800 picofarad. This capacitance is very small, not likely to set the antenna circuit in resonance. These 72 mega ohm may be the internal resistance of the secondary coil R equal to 72 mega ohm. We now continue to calculate the reactance of the secondary coil inductance in the next slide. To verify, I recalculate the inductance of the mini Tesla coil. From slide 23, N2 secondary can be wound with diameters wire size AWG20 equal to 0.81 mm diameter, 2 ampere capacity. Diameter of winding N2 equal to 1.5 inches equal to 38.1 mm. Radius equal to 19.05 mm in 10 layers. There is center tapped at 2.5 turns. Only half of the primary is operating at one time. N2 equal to 2.5 times 14,400 volt divided by 11.75 volt equal to 3,064 turns. L equal to 0.81 times 10 to the power minus 3 times 3,064 divided by 10 layers equal to 0.24818 meter. Inductance L equal to mu naught n square times area divided by length equal to 4 pi times 10 to the power minus 7 times 3,064 square times pi times 19.05 times 10 to the power minus 3 square divided by 0.248181 equal to 12.5664 times 10 to the power 7 times 9.388 times 10 to the power 6 times 3.1416 times 362.925 times 10 to the power minus 6 divided by 0.248181 equal to 134,500.7818 times 10 to the power minus 7 divided by 0.2418 equal to 556,248.0367 times 10 to the power minus 7 equal to 55,625 microhenry. Reactance E equal to J omega L equal to J times 2 pi times 300 times 10 to the power 6 times 55,625 times 10 to the power minus 6 equal to 104.8509 megaohm. Z equal to J divided by 2 pi Fc equal to 104.8509 times 10 to the power 6 imply C equal to 1 over 2 pi divided by 300 meg divided by 104.8509 meg equal to 10 to the power minus 12 divided by 197,639.7525 C equal to 0 farad picofarad. These calculations indicated that there shall be no need to couple a capacitor to the antenna for circuit resonance oscillation. For signal detection, a 4-capacitor series, each 4,700 picofarad, 1,250 volt, total 12 pieces to be installed at the end of the UHF busbar coaxial cable to maintain signal strength and for signal detection by the feedback resistors in the warp drive controller. Capacitor source Okia type HCP B470. Capacitor 4,700 picofarad, 1,250 volt. Source www.alldatasheet.com. Alex Chekhov Demagnetizer circuit modified. Parts required for the circuit as below. For artificial gravity, warp drive. Part number, description, source, manufacturer, quantity. Battery, 12 volt DC, non-specific, non-specific. Quantity 1. VDC 6.2B, Zener dial, 6.2 VDC, 5 milliampere. Alldatasheet.com. Row semiconductor. Quantity 1. KT3102EM, transistor, NPN. Source alldata.com. Integral core. Quantity 2. Transformer, turn ratio N equal to 1250. 12 volt AC, center tapped, plus minus 5.6 VAC. Output 14,400 volt, 2.35 VA. Source unknown. Manufacturer non-specific. Antenna. Professor David Parry's Fractal. Source unknown. Manufacturer non-specific. Quantity 1. Resistor 47 megaohm. Non-specific. Manufacturer non-specific. Quantity 1. Resistor trim port 51k ohm. Non-specific. Non-specific. quantity 1. Resistor 1K ohm, non-specific, quantity 1. HCPB 470 capacitor, 4700 PF, 1250 volt. Source alldata.com. Manufacturer Okaya. Quantity 12. The tabulated quantity is for one circuit. For a deck of 10 times 15 feet, total quantity required may be 300 circuits. Warp drive. We may use a linear motor effect to switch on a series of warps, one after another in a three-phase sequence, red, yellow, blue, to create a warp drive. Consider each antenna in a 90 degrees right angle to each electrode, estimated at 6 inches wide. The horizontal span of one antenna equal to 2 times 0.1524 sine 45 degrees equal to 0.2155 meter equal to lambda. By setting 0.155 meter as the wavelength of the warp, we may make the warp to travel at the speed of light. C equal to 2.997 times 10 to the power 8 meter per second. Then the frequency of switching to be frequency F equal to C divided by lambda equal to 2.997 times 10 to the power 8 divided by 0.2155 equal to 1091 megahertz. This 1091 megahertz is required for switching the IGBT circuit. IGBTs are insulated gate bipolar transistors to be presented in the next few slides. In my previous video presentation, YouTube, Gerard Morin, Hyperdrive Drum Motor Controller Feasibility Studies, I presented the design of the power inverter circuit. Gerard Morin Hyperdrive Controller Circuit Design Feasibility Study, YouTube. I consider this power inverter circuit with interlock logic circuits. Modified may be applicable in this warp drive situation. Antenna circuits in parallel. In slide 14, it was calculated that with 14,400 volts in each antenna, it offers a possibility to interact with 318 kilograms at 0.98 meter per second square. Acceleration compatible to Earth gravity to create an artificial Earth gravity on the deck for astronauts' activity in an Earth-like environment. The human body has mass, electrons and protons, and we are already surrounded with UHF without adverse effect. Will a close proximity to UHF antenna on the deck has any discomfort other than being attracted to the floor as gravity would, and when activated, will the spacecraft be continue to rise up in altitude is to be tested. The spacecraft deck may have length 15 feet times 10 feet wide. Then the deck may need to install 30 antennas units in columns 10 lengthwise and 10 rows widthwise, total 300 circuits. Power required equal to 300 times 42.35 watt equal to 12.7 kilowatt. That is 30 times 10 units. These circuits may be connected in parallel. There may be concerns about the unit UHF signal may not be in phase. I consider each unit shall move electrons to keep the antenna tips polarized. Each circuit shall balance itself. The spacecraft deck, floor material to be used, shall be a research topic. Iron steel is a magnetic material. Is it favorable for creating the artificial gravity environment? The aluminum alloy, non-magnetic material, not permeable to magnetic field. Can we use the perforated aluminum alloy plates for flooring is to be tested and applied as appropriate. Parallel connection of antenna circuits. This is the magnified diagram for parallel connection of antenna circuits. Full power for artificial gravity. Sequential switching for warp drive. Gauge drive circuit. First, I need to change the LM555 timer capacitor to adapt to new frequency. F equal to 1391 MHz. We solve the LM555 timer manufacturer's design guideline circuit equations. Modulation time, Tm. 3 times Tm equal to 1 over frequency, equal to 1 over 1391 times 10 to the power 6, imply Tm equal to 24 nanosecond. In order to achieve light speed c equal to 1391 MHz, I proceed to set T1 equal to 2 times Tm, equal to 48 times 10 to the power minus 9 seconds. T2 equal to Tm, equal to 24 times 10 to the power minus 9 seconds. Charging time, T1 setting Ra plus 2 Rb equal to 100 megaohm. Then 48 times 10 to the power minus 9 equal to 0.693 times bracket Ra plus Rb close bracket times C. Equation 1. Discharging time T2 24 times 10 to the power minus 9 equal to 0.693 Rb times C. Equation 2. Total period T1 plus T2 72 times 10 to the power minus 9 equal to 0.693 times bracket Ra plus 2 Rb times C. Substitute C equal to 72 times 10 to the power minus 9 divided by 0.693 times 100 meg equal to 1.3896 picofarad. Round off, C equal to 1 picofarad for 1391 MHz. The rise time and fall time of the LM555 timer is 100 nanoseconds each. One switch on-off may need 224 nanoseconds. The maximum switching frequency F equal to 1 over 224 nanoseconds equal to 10 to the power 9 divided by 224 equal to 4.46 MHz versus the required 1391 MHz. The logic gates can switch at 10 nanoseconds is not a problem. The resistor Ra equal to 33 megohm, Rb equal to 67 megohm shall remain the same as 1 on 2 off per cycle characteristics has not changed. Only the frequency changed to 1391 MHz. For slow speed testing, we might set at 15 miles per hour, Tm equal to 0.008 seconds, C equal to 350 picofarad. Details calculated in the slide 42 for steering. To be realistic, I need to change the LM555 timer capacitor to adapt to new frequency, F equal to 4.46 MHz. We solved the LM555 timer manufacturer's design guideline, circuit equations, modulation time Tm. 3 times Tm equal to 1 over F equal to 1 over 4.46 times 10 to the power 6, imply Tm equal to 224 nanoseconds. In order to achieve warp speed, 4.46 divided by 1391 times C equal to 0.0032 C equal to 4.46 MHz. I proceed to set T1 equal to 2 times Tm equal to 448 nanosecond. T2 equal to Tm equal to 224 nanoseconds. Charging time is Tm. Setting Ra plus 2Rb equal to 100 megaohm. Then 448 nanosecond equal to 0.693 times Ra plus Rb times C. Equation 1. Discharging time T2. 224 nanosecond equal to 0.693 times Rb times C. Equation 2. Total period T1 plus T2. 672 nanoseconds equal to 0.693 times Ra plus Rb times C. Equation 3. C equal to 672 nanoseconds divided by 0.693 divided by 100 meg equal to 969.697 nanofarad equal to 0.9697 μF. Round off equal to 1 μF for 4146 megahertz. Type GSG 384 Sprague Goodman capacitor 1 μF 250 volt. Radio Maya metal film capacitors. Source dgkey.com. The resistors Ra equal to 33 megaohm, Rb equal to 67 megaohm shall remain same as the 1 on and 2 off per cycle characteristics had not changed. Only the frequency changed to 4.46 MHz. For slow speed testing, we may set at 15 miles per hour, Tm equal to 0.008 seconds, C equal to 350 picofarad. Details calculated in slide 42 for steering. Interlock logic circuit. We shall be connecting and disconnecting the antenna, which contain high voltage at 14,400 volts. The electronics is to be able to withstand the voltage. The interlock logic is necessary to only allow one phase on and two phase off at any time. To implement a feedback potentiometer is to sample the voltage at the antenna that the 14,400 volt is there. Otherwise, error for the gauge and maintenance shall be required. This gauge interlock logic circuit plus the feedback interlock logic circuit combined shall be called the warp drive logic unit, WDLU. Another circuit, gauge driver interlock logic circuit, shall be presented in the next slide. The gauge driver interlock circuit is to ensure that either one of the signal VGRY, VGYB, VGBR is on, to ensure the IGBT gauge to have one on, two off. The next slide is the power inverter circuit for switching the antenna 3 sets each. One antenna to turn on each time. There may be multiple units of antenna required to be installed underneath the spacecraft deck floor slab for artificial gravity when the antenna are on simultaneously. The UHF signal in this presentation is peaked at 14,400 volt. The IGBT insulated gate bipolar transistors each has breakdown voltage of 600 volt DC. So we need 14,400 divided by 600 equal to 24 pieces. To be on the safe side, I use 26 pieces, so that when split in half is 13 pieces each. Total IGBT equal to 3 times 26 equal to 78 pieces. See the next slide. This power inverter circuit is to switch the antenna red, yellow, blue in sequence, RYB, RYB. When GBR is plus 5 volt, the red line is on. IGBTs QB1 to QB13 are on, passing current through the blue common line with feedback resistors, detecting VR to confirm presence of UHF signal. The red phase current returned through the yellow line common, and QR14 to QR26 were on simultaneously due to GBR is 5 volt. Pass current to antenna R. There may be time when the antenna signal is below 14,400 volt. The antenna capacitor C on the antenna circuit is to maintain the UHF signal strength in between the switching to the next phase. GRY plus 5 volt continue to pass current to the IGBT emitters at VREE to turn on antenna R. When GYB is 5 volt, it enables to turn on QY1 to QY13 simultaneously on QB14 to 26 at VBB pass current to the antenna Y. When GRY is 5 volt, it turns on the QR to QR13 and QY14 to QY26 simultaneously on. Pass current to the red line common, return through the yellow line common into QY14 to QY26 at VBBE to antenna B. The RYB are symbolic, synonym to three-phase electricity, red, yellow, blue. The sequence can be changed by interchange of any two antenna wires to get the desired direction. Pass for power inverter circuit. Part number, description, source, manufacturer, quantity. STGF 3NB60FD, IGBT, power mesh, 3 ampere, 600 volt, N-channel packaging, TO-220FP, discrete. Source, datasheet.com. Manufacturer, ST Microelectronics. Quantity, 78. Voltage divider, type 300.4. High voltage divider, R1 equal to 12 gigaohm, R2 equal to 5,200 megaohm, 18,000 volt, 20 gigaohm series, low temperature coefficient. Nicron Electronics, quantity 3. The tabulated quantity is for one circuit, one for front steering, one for rear steering, 3 for lift balancing, one for warp drive. Total 6 circuits required. Pass for gate driver circuit, 4.46 MHz. Part number, description, source, manufacturer, quantity. Timer, LM555, timer package, PDIP8, VCC 5 volt. Source, alldatasheet.com. Manufacturer, Texas Instruments. Quantity 2. Resistor, 33 megaohm, non-specific. Quantity 2. Resistor, 67 megaohm, non-specific. Quantity 2. Capacitor, 0.01 μF ceramic, non-specific. Sprague. Quantity 2. 500 D105 M450 DC2 capacitor, 1 μF, electrolytic. Source, dgkey.com. Manufacturer, Sprague. Quantity 2. NC7SZ04M5X, single inverter, UHS, tiny logic 5 lead, SOT23, JEDEC, MO-178, Moser.com. Fairchild Semiconductors, quantity 2. SN74LVC1G08, single 2-input positive and gate package, SOT5, VCC 5 volt, alldatasheet.com. Texas Instrument, quantity 1. SN74LVCX11SJ, triple 3-input and gate, 14 lead, small outlined package, EIAT, type Type 2, 5.3 mm, alldatasheet.com, Texas Instruments, quantity 1, voltage regulator, LM3940, voltage regulator, 1 ampere, 5 volt to 3.3 volt DC, alldatasheet.com, National Semiconductors, quantity 1. The tabulated quantity is for one circuit, one for front steering, one for rear steering, 3 for lift balancing steering, 1 for warp drive. Total 6 circuits required. Parts for warp drive logic unit, WDLU. Part number, description, source, manufacturer, quantity, MM74 HCT04N-N14A, hex inverter, 14 lead, plastic dual inline package, PDIP, JEDEC, MOS-001, source on semiconductor, manufacturer Fairchild Semiconductors, quantity 1. 74 LCX11SJ, triple 3 input and gate with 5 volt tolerance input, 14 lead small dual outline package, SOP, EIAT, type 2, 5.3 mm wide, on semiconductor, Fairchild Semiconductors, quantity 4. SN74 LVC1G08, single 2 input positive and gate, 5 lead package SOT-23 bracket 5, alldatasheet.com, manufacturer Texas Instruments, quantity 3. TC74 LCX32FT, quad 2 input or gate with 3.6 volt tolerance input and output, 4 lead small outline package, TTSOP, P00044-0.65, alldatasheet.com, Toshiba Corporation, quantity 1. NLX1G332, single 3 input or gate with 5 volt tolerance input, 14 leads, plastic dual inline package, PD1P, JEDEC, MOS-001, on semiconductors, quantity 2. LED, red color, non-specific, resistor, 2 pieces, 470 ohms, non-specific, quantity 2. Voltage regulator, LM3940, voltage regulator, 1 ampere, 5 volt to 3.3 volt DC, alldatasheet.com, National Semiconductors, quantity 1. The tabulated quantity is for one circuit, one for front steering, one for rear steering, 3 for lift balancing steering, 1 for warp drive. Total 6 circuits required. Lotus circuits realization. Up to this slide, the warp drive controller circuit design is complete. The next level of work is to synthesize, build the circuit into circuit boards, and do function testing. As seen in the 3 input and gate integrated circuit package, the gates are already laid out as according to AND gate logic symbol. Likewise, OR gate inverter layout in logic symbols. It is translatable from logic symbols into circuit boards. As I look into the data sheets, nowadays, integrated circuit packages are into surface-mounted SOP versus dual inline package DIP for discrete component circuit synthesis. In manufacturing, the circuits are to be built into printed circuit boards, then use LED light circuit simulator, test all the interlocking functions correct before putting it to high voltage. Without further ado, I proceed with this presentation. Warp drive controller circuit. Finally, the whole circuit is to be realized in block diagram format as these. Warp drive speed limit. We know that a solid spacecraft, non-zero rest mass, cannot travel in speed of light. It is the empty space that has no mass beneath the deck is made to warp sequentially to the speed of light c. This speed is limited by how fast the electronics can switch. In this example, we calculated we need the LM555 timer to switch at 1391 MHz. The actual switch speed limit is 4.46 MHz, as calculated in slide 22. We can achieve 4.46 divided by 1391 equal to 0.003206 C, or 0.32% the speed of light, equal to 0.96 times 10 to the power 6 meter per second. Lift off. On the Bluebird 2, I see antenna on the roof and on the wing, and circled red for balancing the spacecraft. From the model picture, I see the antenna is pointing upward. My next question is, how does the spacecraft lift off? I can understand that pointing the antenna upward, it can create a pulling force. Yet there is only the air, the sky above. Distant stars may be far away or due to Earth environment, atmospheric reflection. The stars seen in the sky are images and not actual location of the star. Pointing to the sun, to the moon is nearer. I consider pointing the antenna up is inadequate for lift-off. When spacecraft is on the ground, the Earth's gravity is stronger than distant stars and planets. When the spacecraft is in space, on orbital plane of the solar system, or same as the horizon of the universe, pointing antenna upward could be all emptiness until the wave reach the edge of another universe. I consider this as a need for another version of antenna to point downwards to interact with the stars and galaxies below the horizon. On lift-off, the antenna shall interact with Earth ground, and the lift antenna shall need to be negative polarized. To have the antenna negatively polarized, antenna pointing down, the UHF electric field shall point upwards towards the antenna. The dynamic electromagnetic field, dq dt, dE dt, dB dt shall have an interaction with the Earth ground, repelling electrons on Earth matter. The Earth is a big reservoir of electrons. The electrons, being repelled, shall spring back, refueled by Mother Earth, and the recoil negative charges on Earth shall repel, react with the antenna. The negatively charged antenna shall have to lift off. In this situation, the antenna circuit shall need to be modified with a half-wave rectifier circuit to separate the positive and negative charges. To negative polarize the antenna, we take the current out, adding in more electrons. The diode D shall guide the current to flow out, adding electrons into the antenna tip. The field dq dt, dE dt, and dB dt are still dynamic in half wave. The negative charges are maintained by C3 and C4 capacitors, negative electrodes. As calculated in slide 24, the antenna capacitor is small to nothing. I shall use a small capacitor to keep the antenna negatively polarized. C1 equal to C2 equal to 12 pieces times 4,700 picofarad, 1,250 volt AC. 12 pieces times C1 equal to 15,000 volt. Likewise, C3 equal to C4 equal to 12 pieces, 4,700 picofarad, 1,250 volt AC, as 12 parallel to 12 pieces can withstand 15,000 volt DC. No need to change. C equal to C1 divided by 12 equal to 4,700 divided by 12 equal to 3,092 picofarad. Manufacturer, Okaya, type HCPB 470, capacitor 4,700 picofarad, 1,250 volt. alldatasheet.com. Note: C3 plus C4 equal to 12 times 1,250 volt DC. 6 plus 6 capacitors for voltage regulation, maximum 15,000 volt DC. Transistor KT3102EM specifications. IC maximum equal to 0.2 ampere. VA in T2 primary equal to 0.2 times 11.75 equal to 2.35 VA. T2 upgrade to 3 VA. Therefore, maximum current in rectifier circuit 3 VA divided by 14,400 volt equal to 0.02 milliampere. This indicated that I can use a 1 ampere diode to support the rectifier function. D equal to D1 equal to D2 equal to 1N 4004. Diode 400 volt to 480 volt, 1 ampere. Suitable. As C1, C2 has taken most of the high voltage, manufacturer on semiconductor. This completes the lift and balancing antenna circuit as shown. We need 12 units of each lifter, 6 antenna up, 6 antenna down, to make one lift and balancing antenna steering to support 2,352 kg at 1 G each assembly. Net effect is 6 units due to half wave. Earth escape velocity. To travel in space, we need to attain Earth escape velocity. VE equal to square root of Gm divided by R. G equal to 6.67 times 10 to the power minus 11 Newton meter per kilogram square. Gravitation constant. M equal to 5.98 times 10 to the power 24 kilogram. Earth mass. R equal to 6.8 times 10 to the power 6 meters. Earth radius. Escape point at 1 R altitude. VE equal to square root of 6.67 times 5.98 divided by 6.8 times 10 to the power 7 equal to 7,658 meter per second equal to 7.658 kilometer per second. From liftoff to V2 equal to 7.658 kilometer per second. V1 equal to 0. S equal to R equal to 6.8 times 10 to the power 3rd kilometer. A equal to V2 square minus V1 square divided by 2S equal to 7.685 square divided by 2 divided by 6800 equal to 0.004312 kilometer per second square. That is 4.312 meter per second square. Acceleration required equal to 4.312 plus 9.8 equal to 14.112 meter per second square. That is 14.112 divided by 9.8 equal to 1.44 G. From previous slide data, one lift balancing unit equal to 12 units of antenna equal to 6 units equal to 1 G due to half wave. There are 3 assemblies on the Bluebird 2 spacecraft. Total pull may be 2,352 times 3 equal to 7,056 kg or 2,352 kg at 3 G minus Earth 1 G equal to 2 G net versus required 1.44 G. This calculation indicated that the 3 times lift balancing assembly together is capable of attaining Earth escape velocity for a spacecraft of 2,358 kg. Steering. The complete lift and balancing antenna circuit is as shown here. We need 12 units, 6 antenna up, 6 antenna down, to make one lift and balancing antenna assembly to support 2,332 kg each. The 6 antenna circuits are doubled to 12 due to half-wave rectifier circuit rendering positive cycle to plus antenna, negative cycle to negative antenna. Doubling circuit in parallel shall strengthen the current, strengthen the magnetic field. To implement a 3-phase linear motor effect to the antenna assembly may help steering the spacecraft to the desired orientation. Red, yellow, blue to be switched in sequence in slow speed for steering. For example, steering at velocity 15 miles per hour, slow as a car. 15 times 1728 times 3 times 12 inches divided by 60 minutes divided by 60 seconds equal to 259 inches per second. F equal to 259 divided by 6 equal to 43 Hz. By setting the modulation time Tm equal to 1/3 of 43 equal to 0.008 seconds. By setting Tm equal to 0.008 seconds, the LM555 timer design equations are: set T1 equal to 2 times Tm equal to 0.016 seconds, T2 equal to Tm equal to 0.008. Charging time T1 setting Ra plus 2 Rb equal to 100 megaohm. 0.016 equal to 0.693 times Ra plus Rb times C, equation 1. Discharging time T2, 0.008 equal to 0.693 Rb times C, equation 2. Total period T1 plus T2 equal to 0.024 equal to 0.693 times Ra plus 2 Rb times C, equation 3. C is equal to 0.0424 divided by 0.693 divided by 100 meg equal to 0.0003463 microfarad. Round off, C equal to 350 picofarad. Ra equal to 33 megaohm. Rb equal to 67 megaohm shall remain unchanged. Deceleration brake. Up to this point, I need to consider how to decelerate and braking the spacecraft. I consider it may be done by reversing the antenna assembly to negative polarized at front and positive polarized at rear. For this reason, I consider the aircraft shall need a rear antenna assembly that is not shown in the Bluebird 2 model. 6 front, 6 rear. Acceleration. Front antenna positive polarized. Rear antenna negative polarized. Deceleration brake. Front antenna negative polarized. Rear antenna positive polarized. Parts for front, rear, and lift balancing antenna assembly. Part number, description, source, manufacturer, quantity. Battery, 12 volt DC, non-specific, quantity 1. VDC 6.2B, Zener dial, 6.2 VDC, 5 milliampere. alldatasheet.com. Rome semiconductor, quantity 1. KT 3102EM, transistor, NPN, integral corp, quantity 2. Tesla coil, turn ratio, N equal to 1225. 12 volt AC, center tap plus minus 5.6 volt AC. Output 14,400 volt. 3 VA, non-specific, quantity 1. Antenna, Professor David Perry's Fractal antenna, non-specific, quantity 2. Resistor, 47 mega ohm, non-specific, quantity 1. Resistor, trim port, 51k ohm, non-specific, quantity 1. Resistor, 1k ohm, non-specific, quantity 1. C1, C2, HCPB 470. Capacitor, 4700 picofarad, 1250 volt AC. 12 times C1 equal to 15,000 volt. Alldatasheet.com. Okaya, quantity 24. C3, C4, HCPB 470, 4700 picofarad, 1025 volt. Alldatasheet.com. Okaya, quantity 12. The tabulated quantity is for one circuit, 12 circuits for front-rear assembly, 36 circuits for 3 lift balancing, total 48 circuits required. Antenna required 6 front plus 6 rear, 36 lift balancing equal to 48 units. Parallel connection for lift balancing. This is the diagram for parallel connection of lift balancing antenna assembly and the circuits. 5-day trip to Mars. On the internet, I found on YouTube, Dr. Paul LaViolette presented Secrets of Anti-Gravity Propulsion, which had a time chart for a desirable 5-day trip to Mars. Acceleration. The suggested acceleration was to be from 0 to 200 km per second in one day. After liftoff, the spacecraft may stay on Earth orbit at altitude 1 r, Earth radius with escape velocity. VE equal to square root gm divided by r equal to 7.658 km per second, as calculated in slide 45. Initial velocity VE to cruising speed V1 equal to 7.658 km per second, V2 equal to 200 km per second, S equal to 1/5 Mars distance equal to 45 times 10 to the power 6 km. Formula V2 square minus V1 square equal to 2AS motion equation. A equal to 200 square minus 7.658 square divided by 2 times 45 times 10 to the power 6 equal to 0.0004438 km per second square equal to 0.4438 meter per second square. Compared to Earth gravity, 0.4438 divided by 9.8 equal to 0.0453 G. One front antenna assembly capable of 1 G, 2,358 kilogram. That is 6 unit front plus 6 unit rear equal to 1 G due to half wave, 12 circuits in parallel required. This calculation indicated that the antenna assembly may cover a 5-day trip to Mars. The forward antenna may be switched off when v equal to 200 km per second. Gravity-assisted space travel. This method has been used on the Voyage 1 and 2 spacecrafts. By making use of the other planet's gravity pull, the spacecraft could swing by, loop around another planet, and accelerate with greater velocity towards the next planet destination without additional propulsion fuel. Gravity assistance to the Moon. After the spacecraft attained Earth escape velocity, VE equal to 7.852 times 10 to the power 3rd meter per second. The Moon gravity force acting on the spacecraft equal to Gm times m divided by distance squared equal to 6.67 times 10 to the power minus 11 times 7.35 times 10 to the power 22 times 2,358 divided by 3.844 times 10 to the power 8 squared equal to 7.823 times 10 to the power minus 5n equal to 0.40 7,734 n. This calculation indicated that the initial gravity interaction with the spacecraft to nearby the Moon is negligible. This means the fractal antenna would serve a major role in Spacewalk at 1G to the 2,358 kg spacecraft at short distance, 35 cm at a time, as the spacecraft travel along in space. 3 days cruising to Mars. Maximum cruising speed at 1G 1 day. V1 equal to VE equal to 7.658 km per second. V2 equal to how many? A equal to 1G equal to 9.8 equal to 0.0098 km per second square. S equal to 1/5 of Mars trip equal to 45 times 10 to the power 6 km. V2 square minus V1 square equal to 2AS. V2 square minus 7.658 square equal to 2 times 0.0098 times 10 to the power 6 times 45. V2 equal to square root 58.6450 plus 882,000 equal to square root 882,058.654 equal to 939.1798 km per second. V2 cruising speed equal to 939.1798 km per second. Ratio 939.1798 divided by 200 equal to 4.6959 times faster than expected. It takes 0.64 days to reach cruising speed. Distance traveled in 3 days at cruising speed. V equal to 939.18 km per second. T equal to 3 days equal to 3 times 24 times 60 times 60 equal to 259,200 seconds. Distance equal to 939.18 times 259,200 equal to 243.435 times 10 to the power 6 kilometer. 3/5 mass distance from Earth equal to 135 times 10 to the power 6 kilometer. Ratio 243.435 divided by 135 equal to 1.8 times faster than expected. It takes 1.66 days using 6 units forward and 6 rear fractal antenna, 12 parallel circuits. 1 day to Mars capture. When arriving Mars, the spacecraft needs to be captured by Mars at Mars escape velocity. Mass capture equal to VE equal to square root of GM divided by R. Square root of 6.67 times 10 to the power minus 11 times 6.4169 times 10 to the power 23rd divided by 6.792 times 10 to the power 6 equal to square root of 6.3016 times 10 to the power 6 equal to 2.51 kilometer per second. Deceleration required. V1 equal to 939.1798 kilometer per second. V2 equal to 2.51 kilometer per second. S equal to 45 times 10 to the power 6 kilometer. V2 square minus V1 square equal to 2AS. 2.51 square minus 939.1798 square equal to 2A times 45 times 10 to the power 6. A equal to 6.3 minus 88,205.70 divided by 2 divided by 45 times 10 to the power 6 equal to minus 0.0098 kilometer per second square equal to minus 9.8 meter per second square equal to minus 1 G. This calculation indicated that when cruising speed to Mars ended, reverse the polarity on the rear to front antenna shall do. The front and rear antenna may resonate with the carbon-oxygen elements in the Mars atmosphere, carbon dioxide, for braking to zero velocity for descent to Mars. When the capture velocity is attained and confirmed capture, switch off the reverse antenna. Let the spacecraft orbit on Mars to find landing place. 1 day to Mars capture. It takes 1 day to decelerate from 939.1798 km per second down to Mars capture velocity at minus 1 G. Total time spent for a 5-day trip takes 0.64 plus 1.66 plus 1 equal to 3.3 days or 79.2 hours to complete at 1 G acceleration deceleration. Mass gravity G equal to Gm divided by R square equal to 6.67 times 10 to the power minus 11 times 6.4169 times 10 to the power 23rd divided by 3.396 times 10 to the power 6 square equal to 4.28 times 10 to the power 13 divided by 1.1532 times 10 to the power 13 equal to 3.714 meters per second square. free-fall time from 1 Mars radius altitude, s equal to half at squared, t equal to square root of 2s divided by a equal to square root of 2 times 3.396 times 10 to the power 6 divided by 3.714 equal to 1,352 seconds or 22.53 minutes. Free-fall landing. Free-fall will work in case of spacecraft has free-fall wing design. When the capture velocity is attained and confirmed capture, switch off the transverse antenna. Let the spacecraft orbit on Mars to find landing place. Apply the brake by reverse polarities of the antenna, tuning in the Mars atmospheric elements, carbon to oxygen, at 460 millionth and 613 millionth harmonic for braking to zero velocity for descent. Soft landing on Mars. On conventional wing design, after a period of free fall, the lift and balancing antenna assembly shall have to apply the brake with 6 up positive, 6 down negative polarized. At minus 1 G, the spacecraft is capable of minus 3 G. The net braking is minus 3.79 G minus 1 G equal to minus 0.621 G. Apply these values into the motion equation. We have V1 equal to 0, V2 equal to V, then V2 squared minus V1 squared equal to 2AS. V squared minus 0 equal to 2 times 0.379 G times 3.396 times 10 to the power 6 minus H. Equation 1. V1 equal to V, V2 equal to 0, then 0 minus V2 equal to 2 times minus 0.621 G times H. Equation 2. Equation 1 plus equation 2. 0 equal to 2 times 0.379 G times 3.396 times 10 to the power 6 minus H minus 2 times 0.621 G H. Equation 3. 0 equal to 0.758 G times 3.396 times 10 to the power 6 minus 0.758 GH minus 1.242 GH. H equal to 0.758 G times 3.396 times 10 to the power 6 divided by 2G. The G is cancelled out. H equal to 1.2871 times 10 to the power 6 meters. This calculation indicated that after a period of free fall to Mars, at altitude H equal to 1.2871 times 10 to the power 6, the spacecraft shall have to brake at minus 1 G to soft landing on Mars. Warp speed to Mars. Distance Mars from Earth. S equal to 225 times 10 to the power 9 meters. Travel time at warp speed equal to 0.0032 c. Time equal to distance divided by velocity equal to 225 times 10 to the power 9 divided by 0.0032 divided by 2.997 times 10 to the power 8 equal to 234,609 seconds equal to 65 hours. 1/5 acceleration time equal to 13 hours. Cruising time equal to 39 hours. 1/5 deceleration time equal to 13 hours. Note 0.32% c is a speed relative to the Earth's inertial frame of reference. To the empty space beneath the spacecraft, there is zero rest mass. This 0.32% c is not subject to relativistic effect. The spacecraft mass shall not change itself. Return trip from Mars. Lift off from Mars. Mars gravity 0.379 g is less than the Earth 1 g, and the spacecraft is capable of 3 g, calculated in slide 45. There shall not be a problem to lift off from Mars. A equal to v2 squared minus v1 squared divided by 2s equal to 2.51 squared minus 0 divided by 2 times 3.396 times 10 to the power 6 kilometer per second squared equal to 0.9276 times 10 to the power minus 6 kilometer per second squared equal to 0.0009 per second squared equal to 0.009276 divided by 9.8 equal to 0.0001 g. Net acceleration required to Mars escape velocity equal to 0.371 g plus 0.0001 g equal to 0.3711 g. Time required t equal to square root of 2s divided by a equal to square root of 2 times 3.396 times 10 to the power 6 divided by 0.3711 times 9.8 equal to square root of 1.8679 times 10 to the power 6 equal to 1366.6 seconds equal to 1366.6 divided by 60 equal to 22.78 minutes to attain escape velocity on Mars. The return trip from Mars shall follow the 5-day trip schedule in reverse. Mars lift-off to Mars escape velocity, acceleration to cruising speed, and then decelerate to Earth capture, free fall and braking, then soft landing back to Earth in 3.3 days. From Mars escape velocity equal to 2.51 km per second, acceleration to cruising speed equal to 939.1798 km per second in 1 day. Cruising speed 939.1798 km per second equal to 1.66 days. Deceleration to Earth capture velocity equal to 7.658 km per second in 0.64 days. Free fall and braking at minus 3 g on Earth. V1 equal to 0. V2 equal to V. V2 squared minus V0 equal to 2 times G times 6.8 times 10 to the power 6 minus H. Equation 1. V equal to V1. V2 equal to 0. 0 minus V squared equal to 2 times minus 2GH. Equation 2. Note, minus 3G plus 1G equal to minus 2G. Equation 1 plus equation 2. 0 equal to 2G times 6.8 times 10 to the power 6 minus 6GH. The G cancel out. H equal to 6.8 times 10 to the power 6 divided by 3 equal to 2.27 times 10 to the power 6 kilometer. At 2/3 of free fall, to apply the brake at 3G, net 2G minus 2G. At altitude, H equal to 2.27 times 10 to the power 6 kilometer for soft landing on Earth. Flight testing. I consider liftoff is the first to be tested on the spacecraft, being on the ground close to Earth's surface within 35 cm, as this is scaled from the modified Cavendish experiment result. In case no liftoff, to have the lift and balancing antenna near to a scaffolded piece of iron plate may enhance the liftoff shorter reaction time for diagnostics. After observing liftoff possible, the next step is to test the forward motion, to have the front antenna point to a solid object nearby, a tree or a wall. The electric field is expected to be able to reach out to recreate the pull. As per the above experiment result, 35 cm took 15 seconds to react. In a test of a solid object at 10 meters away, would it take 15 divided by 0.35 times 10 equal to 428 seconds equal to 7 minutes reaction time. For planetary distance, reaction time shall change accordingly. I consider warp drive is the most exciting test. Start test with slow speed warp, like driving cars at 15 miles per hour, by selection of the LM555 timer circuit capacitor, C equal to 350 picofarad. As when slow speed warp drive works, steering shall work also. Caution: high voltage 14,400 volts is known to produce electric sparks on touching metal surfaces and earthing to earth ground. Caution must be taken to not touch any of the wiring in the circuit. Check all wiring terminations, screws tightened, wires securely fastened, cables properly insulated prior to power on. To prevent electrical arcing, prevent current leakage. The circuit boxes must have label high voltage 14,400 volt AC to alert the end users. Test sites to be posted with high voltage 14,400 volt sign. Testing, servicing, repair, maintenance to be done by experienced, qualified personnel. Keep out of children. Keep out of aerosol, flammable items away from the test site, test benches. Take same precaution as we would for any electrical appliances. Test protocol is necessary to be planned out on human safety issues, crashes, landing, damages, loss of craft, countermeasures to stay in low altitude, 35 cm, 0.35 meter from the ground, until balancing and full control is achieved. Attenuation, inverse square law. The experimental result is effective at 35 cm from the antenna. F equal to KQQ divided by R squared. Due to the inverse square law, the effect may rapidly weaken as the distance extends beyond 35 cm. Calculation: at 4R 140 cm, the force may be down to 6.25%. 1 over 4 square equal to 1 over 16 equal to 0.0625. At 4 times 35 cm equal to 140 cm equal to 1.4 meter. The force would drop to 6.25%. The Vogt definition of electric field. This is the cumulative work done required per charge to bring the test charge Q from R to infinity. E equal to KQ integral from R to infinity 1 over R squared dr equal to KQ 1 over minus 2 plus 1 bracket 0 minus 1 over R equal to KQ over R, units in volt per meter. The force due to electric field would weaken to 10% when the distance is 10R, 10 times the experimental distance 35 cm. Calculation: 1 over 10 equal to 0.1 equal to 10%. At 10 times 35 cm equal to 350 cm equal to 3.5 meter. With less attenuation, the electric field in volts per meter, it offers a possibility that after a movement of 35 cm, another new 35 cm shall come along to take effect to keep the spacecraft going forward. Base support, ground support navigation. Aside from onboard inertial guidance system, global positioning satellite (GPS), ground support for location and attitude of the spacecraft, telemetry data for tracking the whereabouts of the spacecraft. These are already well established in present-day avionics. Life support systems. Astronauts need spacesuit, space food. The spacecraft need to have sophisticated environmental control system for air pressure, air conditioning. These equipment are already implemented on aeroplanes, space stations. This may be planned in for use as appropriate for life support. Conclusion: Professor David Parry's Bluebird 2 working principle is to use time-varying open electric field on a fractal storm cloud pattern surrounded by dynamic positive charges, transmits the information of dq dt, DE/dt, dB/dt in the form of electromagnetic wave to distant planets to pull the spacecraft forward. UHF is used in space telemetry. It can reach out to space. 300 MHz is the beginning of the UHF frequency spectrum. As a tiny harmonic frequency, UHF offers a possibility to resonate the core electrons of abundant elements on Earth, Moon, Mars, and space. Lift-off from Earth is a prerequisite for space travel. With 6 units up, 6 units down in one lift-off balancing antenna assembly, it offers a possibility for the spacecraft 2,358 kg mass to lift off at 2G versus 1.44 G required to attain Earth escape velocity, 7.658 km per second. The Bluebird 2 has 3 assemblies. These can support backup for lift-off as well. Professor David Perry's Bluebird 2 model offers a possibility to warp drive at 0.0032 C, that is 0.2% the speed of light. With faster timer than the LM555, the rise time and fall time is to be improved to 50 nanoseconds each instead of 100 nanoseconds each. The one timer at 24 nanoseconds, the timer may switch one cycle to be 124 nanoseconds. Then the switching will be 1 over 124 times 10 to the power minus 9 equal to 8.0645 MHz. The spacecraft may travel at 0.0645 divided by 1,391 equal to 0.0058 or 0.58% the speed of light. With the Fractal storm cloud antenna, it offers a possibility to cover a 5-day trip to Mars in 3.3 days or 79.2 hours at 1G acceleration deceleration. These mechanics indicated a continuous 1G can go a long way in space travel without the need for initial high G acceleration. At warp speed 0.0032 C, it offers a possibility to cover a trip to Mars in 65 hours. Artificial gravity is one of the special features in the Bluebird 2 spacecraft, with the experimental result scaled to 14,400 volts for electric field. It offers a possibility to recreate 9.8 meter per second square simulated gravity on the deck. Astronauts shall immediately adapt to Earth conditions for activities on board the spacecraft. This artificial gravity offers an extension to the future, mankind living on other planets, the Moon or Mars. We may install such fractal storm cloud pattern antenna on the floor in our outpost facility, and we may adapt to Earth gravity conditions on Mars within the outpost facility immediately, without the need for moving parts, centrifugal exercise facility. Gravity assist for space travel has already been used in the Voyager 1 and 2 spacecraft. When the spacecraft has exceeded the Earth escape velocity, the spacecraft shall lock onto the nearby planet, the Moon as the next destination, without propulsion for gravity assist. Although the initial gravitational force may be small, the spacecraft may swing around the Moon while locating Mars and then accelerate as a natural path to head on to the next planet, Mars. Thank you for watching. This completes my presentation. This presentation is based on Professor David Parry's modified Cavendish experiment result and scaled to known electronic circuits in my studies. I wish this presentation shall add on to the knowledge of Professor David Parry's Spacewalk and warp drive technology. I wish this presentation to be helpful to the knowledge seekers, researchers, engineers, students for continued research on the topic of space travel and warp drive. Thank you, Professor David Parry, for his knowledge on spacewalk. Thank you, Mr. Bruce Gernon. Thank you, good stuff. Thank you, Mudfossil University, Roger. Thank you, Dr. Ling Li. Thank you, Physics Explained. Thank you, AK Lectures. Thank you, Pompei Yonri Fuji. Thank you, Wikipedia. Thank you, JPL. Thank you, Dr. Paul Laviolette. Thank you, Alex Chekakov. Thank you, knowledge seekers. Thank you, YouTube. Have a good day. Peace to the world.